Now we'll look at compounds of two metals of group 4 that are tin and lead. Tin easily reacts with hydrochloric acid to make SnCl2, tin2, and water and hydrogen. Tin oxide will react with HCl to make SnCl2 and water. However, if you run reaction with halogens, you'll have bromide and chloride in cell. So Sn plus 2Br2, you have tetrabromide, which will be tetrahedral molecular compound, which is solid that can easily liquefy. Same molecular compounds as germanium, silicon, and carbon will make this condition. However, oxidation state 2+ is more characteristic for tin because 5s2 group of Sn2+ cation is relatively stable. So when iodine reacts with tin, you will not have SnI4, you have SnI2 instead. SnBr4, same as SnCl4, will react with water, making tin oxide hydrated as a solid, and hydrobromic acid. Same with chloride, will have hydrochloric acid. Tin oxide is insoluble compound, however, addition of concentrated hydrochloric acid can dissolve it upon boiling. Tin 2 chloride can easily dissolve in water to make Sn2+ hydrated ions and chloride ions. It's colorless salt. In gas phase, however, it can make a molecule with lone pair coming from s electrons, like this. Lead oxide is solid that can react with HCl to make PbCl4 in absence of water, which is liquid stable only at low temperature and decomposes upon slight heating. It's again tetrahedral as all tetrachloride. Now when it decomposes, it makes white crystals of PbCl2 insoluble in water. Lead makes several oxides. Of them, PbO is yellowish. Mixed oxide of oxidation number 2 and 3 is bright red. It's so-called lead paint. Very famous paint, are very toxic. And actually, because of this, has some uses. If you want to paint something on which no algae or bacteria will grow, you use lead paint, remembering that it will be toxic for humans as well. Lead 4 oxide is crystalline black solid, reacts with acid to make salts of 2+ lead, PbSO4, PbNO3, PbCl2. It can be made electrochemically. Lead deposits on anode, not on cathode as metal, but on anode as lead oxide. This is a way of separation lead from any other metals. One of uses of lead oxide and lead sulfate is lead battery. In lead battery, one electrode contains PbO2, lead in oxidation number 4, and another metal lead, and they are separated by approximately 50% sulfuric acid. When battery discharges, the reaction is as following. PbO2 takes 4 protons and sulfate and 2 electrons to make lead sulfate and water. Lead takes sulfate to make again lead sulfate and gives away 2 electrons. So electrons are coming from here to there. And now discharge battery will have lead sulfate on each of electrodes mostly, and sulfuric acid will be diluted because the reaction produces water. Now this process can be reversed several hundred times, and you are again making lead out of lead sulfate and PbO2 out of PbSO4. The battery has several elements, usually 6 of them.